Okay, we're on the last bit of the assignment now, which is assessing the suitability of different types of substance for a specified use. And our use is a drill head. And we have three possible substances that we could make it out of. We've got diamond, we've got titanium, and we've got aluminium oxide. So, what did it say we had to do? It said we had to identify the ideal properties from a material used in the manufacture of drill heads. That's the first thing it tells us to do. So, well, I'm moving it the wrong way now. So, our drill head. Had a quick discussion with the little science team, and we came up with this. We thought that the material that you would use would have to be hard. It would have to be not brittle. So when you put your drill onto whatever it is you're drilling through, you don't want your drill bit to fracture. We thought it would need to be strong, and we thought that actually, because when you are drilling something, you probably won't have drilled anything yet, but if, you know, when you're putting shelves up at home and you get your drill, the drill bit actually gets quite hot. So we were also thinking that potentially this would need to have a high melting point, because anything low melting point would melt as you were drilling. And I suppose it depends where you're using it, but you know, you want to be able to carry it, so it might want to be lightweight. You might think about resistance to corrosion. There are a number of things that you possibly could have come up with as well. So let's start with diamond, because diamonds are a girl's best friend. So, what do we know about diamond? We know that it's a giant covalent substance. And therefore it's got strong bonds. And if you remember, or if you look it up even, you'll know that every carbon is bonded to another 4 carbons. Those are very strong bonds. Therefore it's a very hard substance. It's got a very high melting point. Oh, talking of drilling, I think it's probably the microwave, but it sounds like a drill.
Drilling, some drilling.
So obviously, if it's hard and it's got strong bonds, it's also going to be strong, and it isn't brittle. So we moved to titanium, and again, you know, anything about titanium, I had to look it up on the internet. And what I found about titanium is that it is very lightweight. It's strong. It doesn't corrode easily. It's a metal. It has a high melting point. And I was thinking, well, okay, it's not brittle. So already, thinking back to my drill bit, both of these seem to fulfill all criteria. And then I found out that actually titanium loses some strength at temperatures of bigger than 430 degrees centigrade. So at that sort of tip of the drill bit where it's biting into something, I'm thinking, well, maybe that's not as good. We'll have a weigh up in a minute. So, on to aluminium oxide. What do I know about aluminium oxide? It's ionic. So it's one of those ionic giant structures. So therefore, like the others, it has a high melting point. So that's really good. And then it all went pear-shaped after that, because this turns out to be a white powder. So it is crystalline. And therefore it's brittle. So that doesn't seem to be quite as what we're looking for. So then we have to assess what would make them good, what would make them bad. So you could go through and go, right, okay, so aluminium oxide has a high melting point, that would make it good for a drill, but that would make it bad for a drill bit. Lightweight, strong, high melting point, not brittle, all good for drill bits. If it gets very hot, it might lose some of its strength. That will make it not very good for drill bits. Diamond, hard, high melting point, strong, not brittle. I would go for this one, I think. There wouldn't be too much of an issue if you went for titanium, I don't think. I think if you went for aluminium oxide, I'd be thinking, do you know anything about chemistry at all? Are you thinking for yourself at all? But again, you have to explain, these are the good points of these, you know, and then think about, what do you know about diamonds? Woo! They're expensive. So you might go for titanium on the basis that it's a bit cheaper and kind of, you know, hope that the drill doesn't get hotter than 430 degrees at its tip. And discount diamond on the basis of its expense, and that you'd rather make a ring out of it. Okay,